towards multidisciplinary learning. Hello everybody, I'm Erkki Laitila, a systems thinking professional with a strong background from IT systems. In this presentation I will introduce science as a model as well as multidisciplinary thinking using GoodReason, which is a specific technique to present systems and to create conceptual models about systems. GoodReason is a free collection of best practices using systems thinking methods. It also contains ways to document output of systems thinking processes as a dissertation to be presented into academic or practitioner audience. Cyber thinking is here a concept to describe modern society as an extending, self-organizing machine which seeks new directions everywhere in multiple ways. This video is an introduction to the next videos that describe various demos built from this principle as a whole. This video set is to promote multidisciplinary thinking in society because society is needing this kind of skills more and more. As a software specialist, I have created hundreds of computer projects using various languages, architectures and development methods. Therefore, I understand the concept of system as an artifact which is very typical when developing software. However, most persons in society do not know principles of modeling at all, which development process is everyday life in creative software or simulation applications. That is why the information of this video is very valuable for practitioners from any professional area. It has been said by George Box that all models are wrong, but some are useful. It's true also in systems thinking. You can create systems in your brain in multiple ways, and not all of these models are useful. However, by using some practical schemas, the user can create, update and validate one's current knowledge into the most promising direction, more complete in order to become closer to the solution. My motivation is to promote better understanding society in general by the worldwide audience. My background contains 20 years writing challenging applications into industry, including telecommunication industry in Nokia, which was my first job. In my PhD dissertation named Symbolic Analysis, I studied Java compiler and semantics. I modeled compilation and interpretation and virtual machines using an architecture which work gave me much for this novel systems thinking methodology. Many skills captured from software development are common skills with systems thinking activities. Some of them are problem solving, modeling, systems analysis and simulation. Some well-known authors here are Peter Checkland, Peter Sanger, Ronald Akkoff and many others. Contribution from GoodReason to worldwide systems thinking society will be to promote and provide IT-specific ideas and methods in order to teach to the society what is originally the concept of system and how its architecture can be used in any tools to improve society. I argue that system should be an architecture to enable understanding it in all of its semantic meanings. It's a known megatrend that the amount of information is increasing both in real time and cumulatively. Along to the laws of thermodynamics, it's a known megatrend increases its entropy, which makes it the more and more complex. It causes fragmentation and difficulties to understand causal relations, and even worse, understanding chaotic relations. In this slide, I show the principal information flow from a certain source, Wikipedia, to the reader via certain thresholds. Every step requires some energy and some skills from the relevant system to master it. Each step can be regarded to be a typical system to transform its input to its output. The step can be manual or automatic. During my software career, I wrote translators and porting tools from any programming environment into any other. Our product was named Any to make its job in conversion, so-called Kobo to Java translator, resembling one step in the slide. I used their grammarware, certain technology to express grammars of any notation. In the process model of this page, the steps are logical operations, selections, collections, filters, and so on for the information. The user is a system to make the any transformation either in his or her brain or using any other tool, computer or network. Wikipedia has been drawn as the first node because it is a good example of a large information base. Its pragmatics forms a rather reliable knowledge base for a typical reader or student to learn more. GoodReason provides methods to model information with its user in any step, including the nodes of the Wikipedia system architecture. This presentation is open to new theories and information sources for the user to study, to accept or reject. Transformation theory is one rather abstract theory to define systemic changes in general. It's true that most phenomena of nature and society can be presented as processes that transform something from input to output. For example, behaviorism is a methodology to study persons, message, automation, society, etc. in the principle of the figure. When systems thinking is used, it's possible to articulate the object as a system, but furthermore, in most cases also the input and output can be modeled as systems. When the model of the target area is coherent with known system limits, it's possible for the user to validate systems and their interconnections, comparing all of them with the known rules and assumptions. Understanding the whole is, in this way, leads to a problem isolation approach, how to map and study the area. The scope of multidisciplinary learning is very large. Popper's fantasy about 3 worlds is here relevant. The physical world is represented by physics, the mental world is represented by experience and feelings, and the Platonic world is represented by mathematics and other intelligence and tools in general. There are many interpretations about this Popper model. Anyway, When creating new knowledge and new learning for the user and the reader with their stakeholders, this new information can be thought to be separate from the reality and experience because it's new. When creating new information in an assumed world number 3, we can use any methods that are useful. Systemic schematics and principles are here most useful in many cases because this system in our brain can contain information of any type from any approach if we are able to group and classify it correctly. It is said by Ludwig von Bertalanffy that every discipline has the same body, same characteristics. The term purposeful system is created by Akov and his colleagues. This term is useful in studying any new topic if the status of the staging system is not exactly known. Akov explains that the purposeful system has its purpose and it is able to set goals in order to get success. In this GoodReason schema, it's a PowerPoint smart object. The origin and the original purpose is number 1 on the top. The opposite for it is number 8, the final. Then system tries to satisfy its needs using all sectors of the figure. This figure combines many system-specific notations. Most of them are well known in software industry, but rarely they are used in the same figure at a time. Numbers 2 and 7 are opposites, theory and practice. Numbers 3 and 6 are opposites describing flow through the system. Numbers 4 and 5 are also opposites. The former is to unfreeze, to create new, and the latter is to freeze, organizes. This simple model is rather expressive. It is used in this video to describe information of Wikipedia. Understanding what is science is not easy. However, understanding meta-science is easier. This definition has been captured from 3 different Wikipedia pages. Systems thinking is useful to learn any of those principles: science of science and societal interconnections. However, understanding philosophy is quite difficult for any researcher. Some models of philosophy can easily be drawn, although understanding them can take tens of years, even from a professor, to convince himself or herself. This figure shows practical value of the GoodReason intentionality schema in order to model a so difficult topic as meta-science. The synonym is systemics. Meta-science has its origin and finally a long period worldview eternity. Axiology is an input for a researcher to define systemic concepts as outputs. This model can be used for building a new faculty for a university or for adding many scholarships together. For any sector, numerous course notes can be found in Wikipedia. This model is an application from meta-science describing Wikipedia at work. It shows a step-by-step development of system sectors. On the left-hand side you can see definitions for that context for numbers 1 to 8. The worldwide Wikipedia Society has contents and roles typical for the definitions of all sectors. This process is explained better in coming slides. It is essential to emphasize the approach of systems thinking and good reason in the introduction of the presentation. We use instrumentalism as a methodology, using theories as they are true, not checking their validity and relevance in practical situations. Therefore, it is important for any user to select his and her theories and principles correctly. Instrumentalism works like most methods in software development. Most of them have a large theoretical area to use, but in practice only some methods are good enough to be used in real life. Anyway, systems thinking with good reason allows building models almost about anything. In the figure, output from a systems thinking session is got from theories A, B and C with a relevant context, which can define situation, environment, stakeholders, etc. Here we summarize what is learned. Origin for thinking comes from reality, the real world, number one. Mental world and all artifacts are built in interactions, and it's rather complex another world. There are many theories what is the world 3 like. Here we assume that it's a growing knowledge base which is useful for anybody who want to learn more, but surely for persons who want to affect the worlds 1 and 2, causing feedback loops and self-organization capabilities. In the following presentation we describe the political system and the economical system as certain nodes of the wall. This workflow stimulates creativity because you can select anything from any topic to be regarded as a system in the larger supersystem. Archetypes of systems are machine, organism and network. Also they can expressed as mindless, uniminded and multi-minded, according to the category of 6th place of hierarchy. The last definition in this video is for cyberthinking. It doesn't have an exact definition, so we can define it here. Cyberthinking means a system which is able to think globally of any topic from and about any place, purpose, granularity and taxonomy. Definitions for sectors of cyberthinking here can be released in many ways. This set of sectors is used in the coming presentation, where some demos are international and some are from Finland. Cyberthinking is a promising concept because it models a typical person or an organization or a state who is improving its capabilities in order to succeed better in future. As a result, from cyberthinking, millions and millions of combinations of reasoning can be observed. This is to summarize the introduction part of multidisciplinary learning. The main issues are understanding society, multi- and transdisciplinary approach, meta-science, instrumentalism, GoodReason semas, learning, Popper's three worlds, systems thinking, and cyber thinking. The topic is not easy, but understanding what is the system and systems architecture, they help much in order to understand anything as systems. It's a challenge, but it's worthwhile learning. Therefore, systems thinking is an excellent lesson to be learned at school already in the preliminary classes. Waterfoundation.org is an American society to promote systems thinking at school in USA. Thank you for the interest to this introductory part of towards multidisciplinary learning. You can select next video either from YouTube or pressing the title in the page. I hope that you enjoyed this abstract generic presentation. Understanding world is nowadays very important because of its growing complexity. Let's understand the world as system, and let's assimilate the systemic worldview to see the whole above all that happens. Many thanks again. Regards, Erkki.